Hey there, my name is Jack Lardner, and this is my first math educational video. Thank you for tuning in. I appreciate it. So what we're going to go over today is binomial multiplication. So first let's go over what is binomial multiplication. We find in algebra and a lot of other math classes as you go up that a lot of times you end up having to multiply the sum of two terms times each other. Sum or difference. So you can see right here we have some unknown number x, and it's being added with 8 times an unknown variable x minus 4. Now this may seem a little daunting at first. You don't really know quite what to do with it. You got these unknowns and it's not in a very neat form, but there is a way we can multiply this out, and it's called foiling. At least it's the more improper name for binomial multiplication. And FOIL is an acronym. FOIL stands for first, outside, inside, and last. And this is a very important acronym to remember. Binomial multiplication is something that happens at pretty much every level of mathematics, unless you get into like really high levels, but it all builds on top of each other. So let's go over what that actually means. We'll take this example of the x plus 8 and the x minus 4. So the first thing we're going to do is we're going to multiply the first terms. So the first terms here would be this x and this x, and we're simply going to multiply them by each other. So we're going to get x squared. Then we're going to look to the outside. So we're going to take our x and we're going to multiply it, because that's on the outside, times the other outside term, negative 4. Negative 4 times x is just going to be minus 4x, and you would just simply subtract that from the previous term. Next we look to the inside, and the inside terms are going to be this plus 8 and this x. So that's just going to simply be positive x, and you would add that. And then finally you would go to the last terms, and that would be plus 8 and minus 4, and that would just be negative 32. And if you realize these are like terms because they both have the x at the end, so this can be rewritten as x squared 8 minus 4 is just going to be 4x minus 32. So it's a pretty simple, method. You remember it pretty well, especially how often you have to use it. But a lot of times what we find in math is it's not enough to just say how it works, but we also have to discuss why it works. So let's go down here and give you an example, kind of a proof of how it works. So let's just take some unknowns. A plus B times C plus D. These can represent anything. They can represent, something like an unknown x, or they can represent real numbers. And we're going to try and multiply these together. Now, you could just FOIL it out, just like we did before. So first, it's going to be AC. Outside, A times D is just going to be AD. Inside is going to be B times C, so just BC. And then last is going to be BD. But we don't really know why that works, so let's go over that now. Let's construct a rectangle. But let's use the fact that these are being added together. So let's say we have some length A, and it's being added to some length B. So that's one side, A plus B. Remember, these are representing numbers, so the total length would just be the sum of these two. And let's add another side to this rectangle. Let's have one length C and one length D. And now, if we find the area of this rectangle, let me get a better drawing of that. Oops. Something like that. It's not the best rectangle, but if we found the area of this rectangle, it would be equivalent to multiplying these two together, because the area of a rectangle is just length times width. So what we're going to do is we're going to construct some lines here. Basically, we're going to split this rectangle into a bunch of smaller rectangles. And then by finding the area of those smaller rectangles, I'm just going to try and redraw it a bit better here, we can sum all of those together and find the total area. So I'm going to rewrite all these measurements across the board so we can see them better. All right, let's break it down into these smaller rectangles. So this rectangle right here, I'll highlight it. That's just one rectangle, but we know the length and we know the width. It's just A and C. So we multiply those together and we get AC. Now let's go to the rectangle below it. I'll highlight it again. We're going to go for this one right here, this big one. And now we know our length is B and our width is C. So the area of this one, we just multiply it together, area of a rectangle, BC. And we continue this for the rest of them. This one would be B times D. And the last one would be A times D, AD. And now, if we add all of these together, we should get the area of the whole rectangle, which is also equivalent to this. So, and if you notice, you probably noticed already, it's AC plus AD plus BC plus BD. And that is the exact same as what we get when we just FOIL it out. So that's where it comes from. There is another example I'll go over, and that is if we have two of the exact same terms being multiplied. Now, you might recognize that we could also just write this as a plus b squared. And this is a very similar process. You know, you could FOIL this out and you would get a squared plus ab plus ab plus b squared. And you notice these are like terms, so it becomes a squared plus 2ab plus b squared. And it's just the same process. This time, though, it's going to, the shape on the outside won't be a rectangle, it'll be a perfect square. So we have one length A, one length B. Those are being summed together. And we have another length B and another length A. It isn't drawn perfectly to scale, obviously, but if it were, this would be a perfect square because both side lengths are equal and these are right angles in the corner. And it's just the exact same process. So this would become the b squared part. This larger square right here, this is just a and a, so this just becomes a squared. And these two rectangles are the AB parts, and you can see they're exactly the same, so there's just two of them, and that's where this 2 comes from. So it's a very simple process, but it's still very important to mathematics in general as you go into more high school courses. So if we scroll down here, I have some examples for you guys to try. If you go to my website, which will be linked in the description of the video, and you find the post that this is on, you can review a practice sheet where you can find the answers to these, and you can find more practice. On the post, there will also be a Python code that you can run that will give you virtually unlimited practice. But that will be added eventually if you don't see it immediately. Thank you very much for tuning into my video. I hope you enjoyed.